Welcome. In this lecture, we are digging into a little bit of maths, but don't worry, it's not scary when you are doing it with the purpose of a game. The main reason people are scared of maths is because when they were taught it, they never really had an application. So we're going to be revisiting it and giving you new confidence. How are we going to be doing this? Well, we're going to be calculating the distance from home. So very simple. We're going to be doing addition and subtraction, but we're doing it with variables, so that's cool. The computer's doing it for us, so it's basically a calculator. And furthermore, we're going to learn how we can do addition with strings, which is a very interesting thing, which will allow us to put this distance on the same line rather than on two separate lines in the Unity console. So without further ado, let's dive right in. So far, we have a location and we're able to print out that location to the console. And not only is that location a variable, but well, we can change it whenever we like, and we know about the types of the variables. So how are we doing on pseudocode plan? So here's the pseudocode plan. So far we have we've set a start location and we can print that location, but we're not actually printing the distance from home. In fact, we don't have a location for home at all. So, and then we're going to need to calculate that distance from home. So let's first start off by creating a float for a home. Now, one way I could do this is saying float home location equals, let's say, 2.1f, just for a bit of fun. Now, notice that I've done this all on one line rather than splitting it across two lines like here. Now, that's perfectly valid. In fact, generally, I would recommend doing this because it's fewer lines of code and it avoids some repetition, which just means that there's going to be fewer typos and it's going to be easier for you to read when you come back to it. But I wanted to show you that actually the declaration and the assignment are two separate lines, really. They're two separate things that are happening in this one line. But this is just an abbreviation for that, and that's what you're going to see most often. In fact, very rarely do you ever want to declare something without giving it a value, because then what value does it have? You don't know. So best practice, always declare and assign on the same line, but just so you know, they are two separate things going on there. So one is saying save space for this shape of object, and the other is saying put this value in that object. But as you know, we often want to do the two together, so we never have an empty box. So now we have a location and a home location. We need to calculate a distance. So, well, I guess a distance is going to be another float. But what is it going to be? What are we going to set it to? How do we do these kind of calculations? We really want to find out what the difference between these two is. So let's find out. So these are our types again, and we can perform operations on these types. So you could do an addition of two variables, an integer and another integer, where they have values 2 and 3, and you would get another value come out, a value of 5. So you can do that. You can also do this between different types. So you could have an integer and then add it to a float. And what would you get out? Well, you'd get a float out. And that makes sense because, as we know, integers can be converted to floats, but floats can't be converted to integers implicitly or easily, basically. So how would we go about calculating this distance and printing it out? Well, that is a challenge that is up to you. I'd like you to calculate the distance home. You need to calculate the distance and store it in another variable, which we have already handily created here, called distance. And what values can you mix in addition? So have a little think about that. What are the other types of values we've seen? We can mix integers and floats, but is there anything else that we can mix? And can this make printing easier? That's a bit of a hint. So give this a go, pause the video, and give it a stab. Okay, welcome back. So here we are. We have our distance, and we know that we can do addition. But what does that look like? Well, it's as simple as, I kind of left you to try and guess the syntax here rather than show you, because I wanted to show you how simple it is. This is the addition location plus home location, and we could actually print out the distance here rather than location. I'll call it distance. Let's go over to Unity and hit play. Get 7.1, but obviously that's not correct. I've done an addition here rather than a subtraction, which is what I actually wanted to do. So what I want to do is say this is our home location, this is location. So we need to say, what's our distance home? Well, it is going to be actually the location minus the home location. So that's another operation that's supported. You can have plus, you can have minus. Funnily enough, you can also have division. Well, not so funnily really, as represented with a slash like this, and you can have multiplication. But we'll look into those in more detail in further sections. We don't really need that for the go home section. Addition is enough and subtraction is enough. So we can see that the distance from home is 2.9 meters. Now, strictly speaking, it's negative 2.9 meters because if my location had been -1, then I would need to go in the forward direction to go home. And if it was, as it was, something higher than 2.1, then I need to go in the negative direction. So how do I sort that out? Well, I need to flip this order. That's just a quick maths reminder for you guys. The order of subtraction does matter in this case. And we want to do it this way round. And you'll see that Unity does get it right. It's a very good calculator, and it realizes that indeed we need to go backwards 0.9 meters. And you notice it adds a few decimal places in here. That's just because of slight inaccuracies when we have to calculate floating point numbers on a computer. Okay, so that's, as I said, we can do floats minus floats, floats plus floats, and as I mentioned in the lectures, we can also do floats and integers. That's fairly straightforward. I can just show you this, that I could say distance plus 1. So notice I don't have to save this into a variable. I can do it right here where I would use the value. I can do the calculation. That's called an expression. We'll be using that word a bit more in other lectures too. There you go. You see that's done a +1 indeed. So that works just fine. So what other things can we do that addition with? Well, funnily enough, we can do it with floats and strings. So I could say distance plus distance. So I've got the distance string plus the distance float. I can remove this line now. And if we hit play, sure enough, we get our distance on the same line. And basically what this has done is it's turned it into a string. How can I work that out? Well, if I take this and try and save it into a variable, I'll call this distance string, then this works. We can tell it's not a float because if we tried to change that type to float, it would complain and say, well, this I can't convert, it doesn't fit into the box because this expression, i.e. this string value plus a distance value, a float value, this makes up an expression and creates itself another value, is a string. So it needs to be stored in a string box, like so. But it's enough for us to do that straight into the print statement, like so. And it also neatens up things quite nicely here in the interface. So have we done everything that was challenged? Yes, we have made the print better, and we have been able to mix different values, the string, namely. So congratulations on getting through that challenge. I will see you in the next video.